Happy Wednesday, scholars. I'm here with your lesson for today, along with this really funny cat that I found. As you know, I love cats, so I thought I would include it. Happy Wednesday, let's rock and roll. All right, we are still working on, drumroll please, division. We are still working on division, so let's rock and roll into what that will look like for today. So we know that when we solve division problems, we can use a variety of strategies. The Moby and Annie video from the other day on Monday reminded us that we can use our modeling strategy. We can draw a picture. We can make an array. So if we know how many people we want to split something between, we can make that the number of rows or the number of columns, depending on how you want to rock and roll, and then just put one in each until we have a nice even array. Or we can also skip count. Because we can skip count, because we can make an array, that means that we know we can also use multiplication to solve our division. Yesterday, we talked about how we can turn division equations into multiplication equations simply by moving the groups, that middle factor. So we know the division equation, we read that as our total amount of things split into 4 groups equals 3 in each group. So to make that into a multiplication equation, which might be a little bit easier to solve, we can think about that as moving that middle factor here, the number of groups we're splitting in, moving that to our first part, thinking 4 times some number. In this case, because we know the quotient, we know it's 4 times 3, 4 groups of 3, equals 12. So remember, the total number of things in our division equation is the same number as our product when we flip that into multiplication. I have a special surprise video from not Annie and Moby, but actually Moby has a friend named Tim once we get into the upper grades. I thought y'all could handle maybe a little bit of an advanced video that talks about some of these division reminders. Let's rock and roll.
All right, Chagoons, we did it. We got away with 3 of the biggest capers in history. When we get back to the hideout, we'll divvy up the loot, and we'll all be rich. Rich, I tell you. When we're through, boys, we'll all be driving new Packards and listening to the biggest radios they make. Okay, first order of business. Let's divide the loot from the first job. Hot diggity, just look at all that ice. We got diamonds, 20 of them. Now let's see, there was 4 of us participated in the heist. Crusher, Bruiser, Moby, and me. If we divide things up equally, we each get... Wait a second, how do we divide 20 diamonds evenly among 4 people? Well, yeah, we need to use division to figure it out. Division is basically the splitting of large numbers into equal groups of smaller numbers. In our case, we're trying to divide our loot in between the 4 of us so that we have an equal share. Holy mackerel, 15 gold coins. Pretty soon we're all going to be dancing to Lindy Hop on the Queen Mary. Now let's divide them up. What's up, little Jimmy? Okay, fair is fair. You tipped us off this big score, so we'll divide these coins up 5 ways. Now let's see. How many times can we divide 15 by 5? Yep, you got it. We can divide 15 coins into 5 groups of 3 coins apiece. And you can check your answer by multiplying the quotient by the divisor. If your answer is the dividend, you've done it right. Let's see, 3 times 5 equals 15. Yep, we've got it. That's because division is sort of like the opposite of multiplication, in the same way that subtraction is the opposite of addition.
You may have heard Tim use some words that are a little bit unfamiliar to us, but we do know what these words mean. So I'm just going to quick and fast review the types of terms that we might be more used to using. So when he said the word dividend, basically that's just what we call the total number of things that we're splitting apart or that we're sharing when we are talking about division. So we know that as total. We know that another time we use the word total is when we're talking about the amount we have all together for a multiplication equation. So we know that our total or our product is the same thing. So in this case, when he was showing you how we can use multiplication to check or even to solve our division equations, we know that our total or our products have to be the same. So in this case, when he was using multiplication to check that 15 split into 5 groups is 3 in each group, he did here 3 in each group times 5 groups equals the product. So we know that our product and our total are the same. They're the same. Now, divisor, that's just a really fancy word that means groups. We don't need to know the word divisor yet, so we're just going to call these groups. So we know when we're taking our total amount of things, in this case, the 15 gold coins, we're splitting them into 5 groups. We will get 3 in each group. In our multiplication equation, we know that that can just be one of our factors. So do you notice how these are the same? I'll get my fancy pointer out. These are the same, right? Where groups is the same. So we have 5 groups here that they're splitting them into, or that they're multiplying, and we have 5 groups here that they're splitting them into. Remember, multiplying, we're just combining groups. Dividing is when we are splitting into groups or we're sharing between people. So in this case, Tim, Moby, and their other little henchmen, we're trying to figure out how many gold coins they would each get from their big bank robbery. And we are familiar with the word quotient. We just know that's our answer to a division equation, or how many go in each group. We know that we would also find that this amount right here, 3, each of them got 3 gold coins. We know that we also find that in our multiplication equation right here, because we just know that's how many are in each group that we're combining. Thought I would break that down for you a little bit. All right, so let's get rocking on our practice for today. We are going to continue reviewing division using all of the strategies that we have learned, especially focusing on how we can use our knowledge of multiplication to help us think smarter and not harder about solving our division equations. So let's rock and roll. Question 1, what does a mathematician call the answer to a division equation? I'm going to give you 30 seconds to solve this on your own. Go. Two and 1. I really, really hope that you, if I can move this thing. All right, so which one of these is a correct answer? This is what I'm going to say out loud is what happens in your brain. So Mac apparently agrees. You can hear him barking in the background. What does a mathematician call the answer to division equation? I know it's not product, because product is the answer to a multiplication equation. Absolutely. Quotient, I know that this is related to division, so I'm going to go ahead and give it a check mark, because I'm thinking, yeah, that is what I call the answer to a division equation. Mac agrees. That's why you can hear him barking in the background, because he's like, yep, pick that one, Miss Cupp. I know it's not sum, because sum is the answer to an addition equation. Absolutely. And it's not difference, because difference is the answer to a subtraction equation. So that's not the right answer there. So our correct answer there was quotient. I hope that was what you decided in that 30 seconds as well. We can always mark our answer here. We know that A wasn't our answer, B was, C was not our answer because we know that that's addition. D wasn't our answer because we know that's subtraction. All right, let's rock and roll. Always a good idea to just review those, because we know sometimes they try to trick us up with questions by using what mathematicians use, using those words, but we're super smart, so we're not going to get tricked by that. All right, use the skip counting strategy to find the quotient of 54 divided by 6. So we're going to use the skip counting strategy to find the quotient of 54 divided by 6. I'm going to go ahead and write the equation to remind myself. I'm trying to find what the quotient, or the answer, is to 54 divided by 6. When I use a skip counting strategy, that means I know I'm going to skip count by the group's number, by the factor that we are splitting our total into. Because I know if I skip counted by 54, that just doesn't make any sense, because I only have 54 things. If I have cupcakes, I only have 54 cupcakes that I need to split into 6 groups. So what I'm going to do is I'm going to take this middle number, the groups of number that we talked about earlier in the video, and I'm just going to skip count by 6s until I get to 54, because it tells me to use my skip counting strategy. All right, let's go. Ready? 6, 12, 18, 18, 19, 20, 21, 22, 23, 24. Double check that one because I raised the wrong amount of fingers. 18, 19, 20, 21, 22, 23, 24. 6 fingers are up. I landed on 24. 24, 25, 26, 27, 28, 29, 30. I know 30 plus another 6 is just 36, 36, 37, 38, 39, 40, 41, 42. All I'm doing is raising 6 fingers and then writing the multiple of 6 that I land on when I hit my 6th finger. 42. I know that 2 plus 6 is 8, so this is going to be 48. Oh no, I ran out of room. Not a big deal. I'm just going to come below and finish here. 48, 49, 50, 51, 52, 53, 54. So I got to that total. I got to the 54 number that I need to land on. Now it's my job to figure out how many times I skip counted. So I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I skip counted by, when I skip counted by 6, 9 times, I got 54. The way I can think about this is to check my work. Why not write it like a multiplication equation? Is it true that 6 groups of 9 equals 54? Let's count. I'm going to count by 9s because I like to double check by counting with the other factor. So I'm going to use my finger rolling song to help me remind myself. 9, 18, 27, 36, 45, 54. When I count by 9s 6 times, that's why I have 6 fingers up, I did land on 54. So by double checking using my multiplication strategy, I know that indeed the quotient for 54 split into 6 groups will be 9. So I'm going to type my 9 in right here. If you would prefer to check your work by using the modeling strategy, by drawing your 6 groups and putting 1 in each, maybe put 2 in each, until you put 54 total things, and all not in each of the 6 groups, but 54 total. When you split 54 into those 6 groups, you will find that 9 will go into each of them. You can use that modeling strategy to count. I'm just pushing you guys to use some more efficient strategies. All right, question 3. What multiplication equation could you use to solve 64 split into 8 groups? All right, good thing we checked our work on the previous problem with a multiplication equation, because now we're ready to solve this problem using a similar style. So what I'm going to do is I'm going to write my division equation first. I know that I have 64 total things. I need to split them into 8 groups, and I need to find out, well, how many will go into each of those 8 groups? The question wants me to use the multiplication strategy to go ahead and solve this. So that means I know I'm going to take the groups of number, and in my multiplication equation, I know that always goes first. So it's going to be 8 times. And the thing is, I don't know what goes in this box here. So I'm just going to put that box right here. 8 times something, 8 groups of something, equals 64. Double checking that I know that multiplication and division are opposites. Yeah, they're opposites. That means if I start with 64 in division, I need to end with 64 in multiplication. I see that I set that up correctly, so let's get solving. The way that I'm going to solve this is I'm just going to skip count by 8s until I get to 64. Another way to solve this would be draw 8 groups and put 1 in each until we get to 64. So let's skip count by 8s. 8 plus 8 is 16, plus another 8 is 24, 24, 25, 26, 27, 28, 29, 30, 31, 32. I have 8 fingers up. I landed on 32. I know that 32 and another group of 8 will be 40, because 2 plus 8 equals 10. I can also double check by going 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48. Or we can just think that 40 plus 8 will be 48. 48, 49, 50, 51, 52, 53, 54, 55, 56. Got 8 fingers up, so I need to write that multiple down. 56, 57, 58, 59, 60, 61, 62, 63, 64. So I have my 8 fingers up. I landed on 64. I'm going to stop because I know that's what I'm trying to get to. That's the product I'm trying to arrive at by using this multiplication strategy. Let's count how many times I skip counted by 8. 1, 2, 3, 4, 5, 6, 7, 8. So apparently 8 groups of 8 equals 64. If you don't believe me, let's quick and fast double check our work. by doing the modeling strategy. So let's make 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. Let's put 8 in each and see if we get to 64. Or we can solve it with the division strategy of breaking 64 apart, putting 1 in each at a time until we run out. I'm going to count by 2s because that's just more efficient. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64. So I ran out of things to put in my group. Do I have 8 in each group? Let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 2, 4, 6, 8. Yep. 2, 4, 6, 8. Yep. Yep. If I keep counting, I know that I will have 8 in each group. So we just solved this problem multiple ways because we know that this can represent 8 groups. 1, 2, 3, 4, 5, 6, 7, 8 groups with 8 in each group equals a total of 64. That was the multiplication equation that we can use to help solve this division equation. So I'm going to go ahead and I'm going to write 8 times 8 equals 64. I like to put spaces in between when I type out my equations. I think it looks neater. So I would encourage you guys to do that as well. We know that using our 8 times 8 multiplication fact will help us solve that division equation. We got to add our magic word for today. Our magic word, thanks to Mr. Cody who requested this, our magic word for today is Narnia. If you didn't recognize this picture, it is the cover of Narnia. So you're going to type in Narnia. Make sure you spell it correctly. If you don't put in this magic word, you will not be able to access your independent practice. So watch the videos because it's the lesson, and also make sure you stick Narnia in there. It's spelled for you right here. Narnia, doesn't matter if it's capital or not. I coded both of them. So this is your magic word for today. I hope you enjoy. If you have a special request, personal message me. We'll see what we can do. Now, this wants us to use the array strategy to find the quotient of 64 divided by 8. Well, we used our modeling strategy to double check. We also could have used our array strategy. Super cool that we can be using our previous work to help us solve this problem. So I do know that the answer already is, show me in your hand. Yeah, it's 8 because we just solved that in our previous problem. But let's triple check by using the array strategy. I was just proving to you that it's always a great idea to make sure we put our work on our paper because it allows us to think smarter, not harder. All right, so when we use our array strategy, we know that number here means groups of it, or it means groups. It means groups. That second number in a division equation means groups. So what I'm going to do is I'm going to make that the number of rows I have. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to skip count by 8s, very similar to what we did with our skip counting strategy. But now it's nice because we can also have little dots to count. If you don't have dots to count, you can just use the numbers we wrote next to them as your sort of like fake rows. So I would go 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And then I know that I'm pretty good at skip counting by 8s. The next one will be 40. Then there's 48, 49, 50, 51, 52, 53, 54, 55, 56. So here, we will have 1, 2, 3, 4, 5, 6, 7. And then Miss Cupp was silly and forgot to go to 64. That's why it's always a good idea to double check. All right, 7 rows for 56. So I think if we maybe add another one, 56, 57, 58, 59, 60, 61, 62, 63, 64. So then we can count how many columns we have. I am done adding that last column. I hit 64, so I'm going to stop, and now it's just time for me to count my columns. Drew my lines 1, 2, 3, 4, 5, 6, 7, 8. There are 8 columns. So I know if I split 64 into 8 groups, into my 8 groups, I will have 1, 2, 3, 4, 5, 6, 7, 8 in each group. I know that that's the correct answer because we proved it over here using our multiplication strategy, our skip counting strategy, and our modeling strategy. We're just reminding you of the variety of strategies you can use. I would not expect you to show that many strategies to solve one problem. 2 is always your best bet. All right, so we know then the array strategy, the quotient of 64 divided by 8 is 8. Now, which equation has the same unknown value as 23 divided by 7? 23 split into, 23 split it. Now, number 5, which equation has the same unknown value as 27 split into 3 groups? Equals something. So what this question is really asking me to do is, what equation would it be true for whatever the quotient is in this division equation, so whatever the answer is here, for which equation, if I plugged in this answer, would also be true? So the first thing that I would do is I would look at my answer choices, and I see that some of them have multiplication in them. I see that here's a multiplication sign, here's a multiplication sign. I'm a smart BCP scholar, and I know that sometimes we can use multiplication to solve division equations because they're opposites. So we can write equations that are equal to the same thing with division and multiplication. So what I'm going to do is I'm going to take my division equation and I'm going to just make it into a multiplication equation. I'm not going to solve it because I don't think this problem's actually asking me to solve. I'm just going to make it into a multiplication equation to see if there's any answer choices that maybe look like that. So I know that the total in a division equation is also the total in my multiplication equation. So I'm going to make this equal to 27. I know the total in a division equation is the product in a multiplication. So I'm going to write equals 27. Now, I know that the 3 here means groups. It means the number of groups that I'm going to have because I'm splitting 27 into 3 groups. So I'm going to say 3 groups with my multiplication sign there. But I don't know how many are going to go in each group. So I'm just going to put a box there for right now. 3 groups of something will equal 27. And I can use this to solve this division equation, but let's just see if there's an answer choice that matches this. So I'm looking at my answer choices. I see 3 times something equals 27. Wait a second. That looks super similar to what I just did over here. So I'm going to go ahead and put a check mark next to this because I'm pretty sure that's my answer, but a good mathematician always checks all of their answers. So let's check these other ones. 3 split into, just marking it how you should mark it on your paper. 3 split into some number of groups equals 27. I know that's not the correct answer because if I'm thinking, if I only have 3 as my total and I'm splitting that into some number of groups, it's going to be hard for me to come up with 27 in each group, / impossible, right? So I know that's not an answer because I only have 3 things to start with. If I'm splitting them into groups, I know that this number should be smaller than my total number, and it's not. So that doesn't make any sense to me. All right, let's look at this next answer choice. 27 groups of something equals 3. I don't know about that one because I'm thinking to myself, this number here is definitely going to be a whole number. I can split 27 into 3 groups. Even if I put 1 in this box, 27 groups of 1 is 27. So that's not equal to 3. So it's not my answer choice here as well either, because I know that if I stick 1 into my box here, that's not going to be my correct quotient. So that can't be the same value. Also, just 27 is more than 3, so I can't put that in there. And then let's look at this last choice. So whatever value goes, whatever my quotient is, divided by 3 will equal 27. I don't think this is my answer choice either here, because if I have 27, I'm splitting into 3 groups. My quotient's going to be less than 27 because I have to split 27 up. So if my quotient is less than 27, if I were to take my quotient and then split that into 3 groups, there's no way there could be 27 things in each group. Like, that just would not make sense to me. So I know that that's not going to be my answer choice either. So over here, when you're doing this, you can be writing the answer choices here. I know they're not labeled A, B, C, D, but you can totally do that if you would like to. So we said that B wasn't our answer because splitting 3 into more groups would not make 27 in each group. That would make no sense. 27 groups of something equals 3. That also made no sense because 27 is more than 3. And we know that if we took our quotient and split it into 3 groups, it would be making it even smaller. So there's no way it could be equal to 27 because it's already supposed to be less than 27. So we know that isn't the case. So this question really asked us to be thinking about how we can be using a multiplication equation to solve a division equation. But also we can solve this just by thinking about how big or how small our quotient is going to be. If we know our quotient is going to be smaller than 27, any of the answer choices in which that box has to be bigger than 27 would make no sense. So just checking our knowledge there. That was our correct answer. And then finally, question 6. If 3 times 7 equals 21, or let's read that like a mathematician, if 3 groups of 7 equals 21, then 21 split into 3 groups equals what? If you're thinking, Ms. Cupp, this sounds really similar to that question from yesterday, where if I thought smart about it instead of super, super hard about it, I know that the answer is actually in the question, then you are a mathematician and you should kiss your brain because you're absolutely right. If you think smart about this question, the answer is in it, right? It's telling us if there are 3 groups of 7 things, if there are 3 boxes with 7 cookies in each box, I have a total of 21 cookies. Now, if I want to take those 21 cookies and put them into 3 boxes, how many will go in each box? Yeah, the answer is that other factor that they gave us. The answer is 7. Because think about it. If we were to take 21, split into 3 groups, and just turn that into a multiplication equation. I don't know what my quotient is, but I know that if I have 3 groups of whatever my quotient ends up being, it's going to equal that 21 total. So if we're thinking about like cookies in boxes, like I just talked about, my 21 total cookies that I'm splitting into 3 boxes is the 21 total cookies in my multiplication equation. Now, in the question, it tells us, hey, 3 times 7 equals 21. It tells us that's true. 3 times 7 equals 21. You can quickly skip count by 3s if you don't believe me, or by 7s if you don't believe me. So it's saying 21 to split into 3 groups. There'll be 7 in each group. So that's a way that we can be thinking smarter and not harder in order to solve that question. We can also just look at our other answer choices and prove they're wrong. Think about it. We know that 21 split into 3 groups. Just quickly model it for yourself. If I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How many are in each group? 1, 2, 3, 4, 5, 6, 7. Yeah. So we know it's true. We can solve it. Or that just took me like 35 seconds to solve. But if I thought smarter about it, I knew immediately my answer's in the question. All right, my friends. So we practiced a lot of strategies today. We practiced our array strategy, we practiced our skip counting strategy, we practiced modeling, and we also practiced how to be using multiplication to solve division and how to be flip-flopping those equations. We know that we can do that because they are opposites. They are, which is also what Tim and Moby reminded us in our video. So after you type the magic word from the video, which I believe was, if you forgot it, make sure you go back and watch it. It is Narnia though, so make sure you go ahead and type Narnia. I'll flash the slide to remind you in a second. Once you type Narnia, go ahead and click next, and you are going to practice these same skills under independent practice. I can't wait to see your hard work, and all that you rock and roll on. Also, there's a fun surprise at the end of your independent practice. I hope you enjoy. Great work today, friends.